In this lecture, we're going to go through the three different forms of communication: human to human, human to machine, and machine to machine. Then we're going to talk about the two different kinds of messages and how they relate to electrical principles. The first type of information shared is between humans. Human communication is primarily the exchange of thoughts and feelings, which are more opinion-based messages. Equally important are instructions and locations. Fact-based messages. Also present in this type of shared communication is the sharing of media, like pictures or video, through different mediums like gallery displays, text messages, and social networking. Some of these messages are shared with two other types of shared information, like human to machine and machine to machine. The second type of information shared is between humans and machines. In this form of shared information, our types of messages become more specific. This pattern will be seen as we delve deeper into every level of information and communication. The more absent humans are, the more specific the message has to become. Instructions become coded messages like a script message. Position becomes more specific with GPS coordinates or proximity in distance to a known landmark. Images require more information like the colors inside or the resolution, the size, and so on. The last type of information shared is between machines, where humans are totally absent. While these machines need to be more specific, they can also be more simplistic. When a computer program is reading furnace temperatures at a casting plant like Arconic or FCA in Tipton or Kokomo, they don't need units like Fahrenheit or Celsius. They use resistance measurements, which can be more easily interpreted by computers and machines. Oftentimes, machines translate certain values from ones and zeros to things like 30 seconds or 54 degrees Celsius. In other words, they translate messages from a digital format to an analog format. As humans, we communicate through analog messages. Small talk like "how's the weather?" get the response of cloudy or warm. There are a variety of answers to choose from, in other words. Computers and machines speak primarily in a language of ones and zeros. As language evolved and needed to be shared across greater distances, humanity developed primitive forms of digital signaling, like smoke signals with long and short bursts of smoke to indicate danger or the status of a mission operation. This evolved into Morse code, used to traverse even greater distances than visual in a shorter time frame. Analog messages continued to be developed, especially as more complex ideas needed to be communicated easily. Temperature was given a range unit. Speed was given a distance over a period of time. When compared to digital, analog definitely has the ability to convey more complex messages quicker, but it can be more easily disrupted. Digital messages can be encoded much easier and is therefore the primary form of communication for machines. This next part is really important. The common element between electricity and communication is the transmission of information. To end on an anecdote, around 2009, states began mandating that residents switch from analog TV to digital TVs. The concept was simple: replace fuzzy TV screens with clear resolution TV images. However, in the early adoption of this mandate, many state residents opted for converters to be placed between their analog receptors and their digital TV services. These early converters would not always offer clear signal. Instead, what would happen is that when there was a weak signal, the TV image became pixelated. This happened a lot more frequently than promised, and so TV service conversions needed to get better a lot quicker. While analog messages can offer more information, the simpler digital message can come out clearer.